This video is on relation notation and what a relation is. It's not going to get into how to determine the rule of a table. That's way back in chapter 3, and you can go to that. But we have been looking at tables for a while now, and this table shows a relationship between our input of x and our output of y. We've referred to our input in a few ways. We've called it our independent variable. All right. And we've also referred to as our input. It's the value we're starting with, the value we pick that we're going to put into an equation. And the dependent variable, or the output, is our y value. Meaning when we put x into an equation, that's what comes out of the equation. And we can see they've matched up things here. And if you want to pause the video and try and figure out what the relationship is, go for it. But I see the relationship here is that if I want to find the y value, I have to take my x value, square it, and then subtract 1. And if you test that out with our x values, you'll see that that's true this entire time. Well, this is what we've dealt with. We've dealt with equations, but relation notation is when we take a relationship. Any relationship is anything that starts with an input and gets you an output, so equations work with that. All right, graphs work with that, tables work with that. But it writes it in a certain way. It's going to take this y equals x squared minus 1, and it's going to rewrite it like this. Now, all I did was replace my y with this symbol here. It's got an italicized f. All right, that first letter is not a variable. It's an italicized f, and it gives me the name of the relation. And it starts with f. It could start with any letter we want, but typically f is the most common because most relations we're going to come to see are functions, or at least we'll be dealing with functions, a special type of relation, more frequently. And we'll get more into that in the next video. The next piece, this piece right here, my x tells me my input. All right, so my x is the input. It's telling me the value that I'm going to put into my expression here. And this is pronounced as f of x. All right, when we see it, it's f of x. So the name is f. It's telling me what the relation is, all right, what the input is. And then this here is the relationship itself. And the relationship is used to get my output. Now, my output is technically represented as the entire thing, f of x. This entire statement right here, that whole piece, the name and the input together, represents my output. And we're going to show you how to use that in relation notation. Let's take a look in this next one here. All right. So if this is my relation, as we just saw, and I asked you to find f of 3, well, that means that my input, now replacing x with 3, is what I'm going to put in to my expression. I'm basically going to substitute. And I continue to put this f of 3 on the left-hand side and equals, and on the other side I actually get my output. So 3 squared is 9 minus 1 is 8. And I see that I have 3 parts to my statement at the end, which represents my solution or my final answer. All right? I see the name of the relation I used. I see the input. And I see the output. Those are the 3 pieces you need when you're using relation notation. This relation notation, if I wanted to graph the result, could be graphed using the point 3, 8, because in an ordered pair, x, y, typically this, well, always, is my input, and this right here is my output. My independent and dependent variable, because the x-axis is my independent axis and my y variable is the dependent axis. So those are the pieces of it. Let's just do another one. What if I asked you to do f of 0? Well, then you'd plug 0 in for x, all right, and I'd square it minus 1, and I'd find that f of 0 equals negative 1. Good. All right, so that's basic idea. It's just basic substitution and evaluation there. All right, but why do we use different names? Why f? All right, well, notice here, I've got 3 different relations now. F of x is equal to x squared plus 3x. G of x is equal to 3 over 2 minus x. And h of x is equal to the square root of x. Well, notice when I say f of 4 over here in my first example, that's telling me to use the f relation and input 4 for x, giving me something that looks like that. And if I plug that into my calculator, I can find what the result is or what the output is. in this case, that output is 28. So f of 4 equals 28. G of negative 1 says now I'm going to use the G relation. So I'm going to come over here and I'm going to take my G relation and I'm going to replace x with negative 1. And I can go ahead and simplify that one down as well. All right, careful, it is minus a negative 1, so the bottom gets me 3. And so this whole output comes to 1. And then I can look at this next one, the H relation. H of negative 7 means I'm going to take the H relation, which was the square root of x, and I'm going to put negative 7 in for x. Well, when I try to do this one, we actually come across a little bit of an error because you can't take the square root of a negative, so there is no output represented by the symbol null. Again, this does not mean no solution. This, in this case, means no output because I was not looking for a solution. I was looking for an output. Now, what if I mix it up on you? What if now, instead of writing f of x, the f of an input over top of, hold on one second here. Instead of writing the f function underneath the f input over here, I've now got h over here on the left. I've got g in the middle. I've got f of x over here on the right. Does that matter? Well, no, it doesn't really matter in this case. And I'm going to change this example right here for a moment. We'll make this a 9 just for the point of it. All right. But it doesn't matter that h of 9 is underneath the f relation. All right. It doesn't matter that this is right here. Who cares? That's not the point. The goal is that this tells me, right here, this h tells me which of my 3 relations to use. So regardless of where h of 9 is on my paper, h of 9 means use the h relation and plug in 9. So even though h is over here on the left and my relation was told to me up here on the right, it doesn't matter. The name tells you which relation to use. So in this case, h of 9 is going to be the square root of 9, and therefore h of 9 equals 3. All right? So look at the next one, g of 2. G of 2 just happens to be in the middle again. That's okay. But notice what happens with g of 2. Well, when I plug in 2 here, I get 0 in my denominator. Can you have 0 in the denominator? No, you can't. So once again, we see another no output or null. There's 2 instances where you'll definitely see null. 0 in the denominator, and as we saw last time, taking the square root of a negative, as we saw right there. All right, and our last one, f of x equals 0. Well, wait a second. This one's different. Now, it's telling us that we are still using the f relation. However, it did not give us the input, it gave us the output. F of x, if you recall, represents our output. That's what we talked about right here. You can see it represents our output. So they gave us an output of 0. That means that 0 is going to equal x squared plus 3x. Some value of x is going to make that true. Some input will make that true. And to find the input, we have to actually solve the equation at this point. To solve this equation, it is a quadratic, so the first thing I'm going to do to make sure it's equal to 0, which it is. Then I'm going to factor, pull out my GCF of x. And I'm going to go quickly through this because if you want more information on how to solve a quadratic, go watch that video. All right? But in this case here, we see that x could be negative 3 or 0. That means that our output of 0 is obtained when we use an input of negative 3 or 0. I could write it in input notation, relation notation, like this, showing that an input of either negative 3 or 0 could get me an output, or you could even just say x equals 0, comma, negative 3. The order doesn't matter because it's just 2 things listed. You could say negative 3, 0. All right, but what we're looking at is to just find the value of x that makes that true. All right, let's practice another one. Try this one now. Pause the video, see if you can do it on your own. All right, coming back to it at this point, let's see how you did. Well, f of x equals 40 means that 40 is equal to the relationship of x squared plus 3x. And I want to find the value of x that makes this true. It is a quadratic, so we're going to start by making it set equal to 0. And we're going to go ahead and solve this. Once again, if you find that you are struggling with solving quadratic equations, go back and watch that video. Because here I am just factoring my quadratic once it was set equal to 0 so that I can apply zero product property to find the 2 values of x that make this true. And in this case, we find that x could be negative 8 or x could be 5. 2 options. If I wanted to write it in relation notation, I could write f of negative 8 or 5 gives me an output of 40. And that's what I'm looking to do there. What about this one? All right, this one here represents an embedded relation. An embedded relation means a relation inside of a relation. This one has three relations that we're dealing with, and all of which are embedded in one another. I'm going to make it a little bit easier at first and just take this one off. All right, so we just see 2. All right, and if we see this here, g of h of 9, which is how I pronounce that, g of h of 9, it simply means that I want to start with the innermost relation, h of 9. Well, h of 9 means, as we saw earlier, that I'm going to plug 9 in there, and I'm going to find that h of 9 has an output of 3. Well, that output of 3 is what's going to go in here. And it's essentially going to replace that h of 9, because h of 9 represents the output that we get there, which means that I'm going to use the output from h of 9 as my input for g. So I'm really looking at what is g of 3. Well, if I do g of 3, I'm just going to come over here and plug g of 3 into the g relation, which means 3 over 2 minus 3. And I find that g of 3 is actually equal to negative 3. All right? And that means that negative 3 would be that result here. So what if I go back to the original embedded relation, as that will be the challenge question on a test, where it's got 3 relations that we're dealing with? Well, that means that we're just going to keep going. All right? So if I find that g of 3 is negative 3, well, then I'm going to plug that in, and I'm really looking for that right there. All right, what does that equal? And I can plug in my input of negative 3 into my f relation. And I'm going to actually do that over here just because I got a little bit more room. All right, if I plug that in, I get negative 3 squared plus 3 times negative 3. All right, and when I do that, I find that f of negative 3 is equal to 0. All right, so if this equals 0, then the whole thing in the original, all is equal to 0. All right, it's just what your final result is. So an embedded relation, just start at the innermost relation. Start there, find its output, use that output as the input for the next relation, and keep working your way up. What if I'm not given an expression, though? What if rather I am asked to evaluate a relation just given a table? Well, if you're not given an expression, you're not given a graph, you cannot assume that there's some sort of relationship that can be expressed as a graph or equation. This could just be a list of points. All right? And so if you're given a table, I simply use the table to identify my outputs. In this case, starting with f of negative 3 over here, I see that when the input is negative 3, I get an output of 10. So 10 is my result, and that's it. All right? This is much easier than the other one. F of 2 means I look for 2 as my input, and I see I've got an output of negative 4. So negative 4 is my result. All right? What about f of 7? Do you see f of 7 in this table? I don't see a 7 as an input, and therefore there is no output to go with it. What if I ask for an output of 8 at this point? Well, if I go for an output of 8, then go back to my table and notice I've got an output of 8 here and an output of 8 there, which means there are 2 values of x that will make this true according to our table, negative 1 or 1. All right? And if I wanted to write it in relation notation, negative 1 or 1, I can write it actually like this. I can use that little plus and minus symbol to represent both 1 and negative 1 in this case. Our last thing that they might ask you to do is to evaluate a relation by looking at a graph. Here we see that g of x is just represented by this graph right down here. All right, we can see that because it's titled right there. And what if they're now asking you to go ahead and find g of 1, as they showed us here down at the bottom there. G of 1 they said is negative 1, but why is that so? Well, here they're telling us that x is equal to 1. And therefore I find 1 on my x-axis, which is right here. All right, that is 1. And I'm going to look up and I'm going to look down to find where it touches g of x. Well, it touches g of x right here. All right? And if it touches g of x right there, what is the output associated with that point? Well, the output is my y value, and that's right here, and we see that is negative 1. That's why g of 1 has an output of negative 1. Let's try a few more here. All right? What if I asked you to find g of negative 1? All right, well, go to negative 1. That is right here on the x-axis. There's negative 1. I'm going to trace it up to find there's my point where it touches my g of x relation. And I see that it has an output of 3. I'm basically asking you to just read a point on a graph. What if I asked you to find g of 0? All right, well, g of 0, go to 0. That is right here. All right, and it happens to also be on the x there, so 0 is that point. We can verify that we're doing it right because if we were to write these as an ordered pair, all right, we'd see that the points of those ordered pairs are on the G relation. All right, let's give you an output. What if I said G of x, all right, is equal to, in this case, let's go with 3. All right, we kind of already did that one once there. All right, but in this case here, now I'm giving you the output, so go to the y-axis, and I'm looking right here where I have an output of 3. All right, and where does it touch? Well, it touches here and here. That means there's 2 values of x that will make this true. There are 2 inputs. Well, when x is -1 or when x is 3. Because if we trace it down to our x-axis, we see -1 and we see 3. All right, so we can see, again, if we write it in our relation notation, we see that we have 2 inputs that could get me an output of 3. All right, and that is evaluating a relation using an expression, using a table, using a graph.